While working in interactivity, using interactions with the mouse when we're on a desktop or with your fingers when you're touching devices is a common feature. So when we tap on something, we are using the interaction of something that you're touching. Or in the mouse would be when you click on something or when you move the mouse over an object. All these different interactions are controlled by the user, and we get to determine how that interaction happens. A common concept in these interactions is the concept of friction, and that is to have a delay between the action of the user controlling the item on the stage versus the actual action happening. So, for example, when we look at the example of the game that we saw in class, we have control of the ship, but you'll notice that as I move my mouse, it sort of lags behind in time, waiting for basically before it takes off. The further I am, the faster it goes, but as it gets closer to my mouse position, it slows down. You will also notice that the ship sort of tilts left or right depending on the position of my mouse with reference to the ship. If I am on the ship, anywhere on the ship remains even. Once I get past the right side of the ship, it tilts to the right. If I get past the left, it tilts towards the left. So that delay is what is caused by something we call friction. So how do we program that friction into our programs? Let me go ahead and create a new movie clip. And I'm going to be using an action script based movie clip, the standard that we've been using. And into this new movie clip, let me turn off the actions window for just a second and change the color of my stage to something like a light, nice dark blue. And I am going to use that previous movie clips, this one right here. I'm going to use its library because it contains the ship movie that I want to use for this. As you probably noticed, the ship movie has been already shared for ActionScript, so there's linkage on it already. So let me go to my current movie. I'm going to drag that ship movie clip into my stage on this current movie and the one that I'm working on. Since I've already moved it, you'll notice that it appears now in my library, and I have to take notice of several things here so that I can calculate what I want to do with this movie. So first things first, as you saw in the interaction, if I am over the ship follows my mouse as long as I'm over it, trying to make that reference point right here on the tip of the ship the same position as my mouse. As long as I'm over the ship, over the movie clip, then that means that no tilting occurs. Once I get past the right-hand side, as it moves towards the mouse, it tilts towards the right, and if I get past the left side, it tilts towards the left. So let's go ahead and double-click in this movie really quick. Let me zoom in, and let's examine what that movie clip has inside it. So if I double-click on it, let's take a look at its timeline. You will notice that it has an actions layer with some kind of code in it. So let's take a look at that code, F9. It's a stop action. So basically when this movie plays, it will stop on the first frame. That's what it's saying. And then if I am pretty sure the second one is the tilting action, and it only uses one tilting action. You'll notice that it tilts towards the right, which means that if I'm to the right of the ship, I need to make that movie go to its second frame. When I'm over the ship, it needs to go to the first frame. And if I go to the left of it, I can make it I can create a new frame if I want to, or I know that this will look like it's tilting, so I can go ahead and flip the scale value of the x-axis on this to a negative value, meaning I can make it negative 100%. Therefore, that movie clip will look like it flipped to the other side, making it look like it's tilting to the left. So I have those options to work with. That is how this movie clip is set up. I need to know that. I also noticed that the registration point is at the very center of the ship, on the very tip of the ship. So that is also something that I need to take into account, because when I'm working with this, the right side of the ship will be the center point plus half of the width of the ship. And the left side will be the center point minus half the width of the ship. That is how I calculate where the left and the right side of the ships are. The top of the ship is 0. The bottom of the ship is the height of the ship, as you can see. The distance between that registration point and the bottom of the ship is the height of the ship. So that is the y value, not the y value, the height of the ship. The width would be the width of the ship, whatever the width of it is, And then the right side would be the center point minus plus half the width, meaning x plus half the width. And the left side would be x minus half the width. That's how I will calculate those values. So let's go back to the main scene. And with this, let me zoom out a little bit. With this already on my library, I don't need it on the stage. I can always call it dynamically from the library. So I will create a variable for this to control it. Let me right click on this and go to its properties. Make sure that everything is exported for ActionScript, that the class name is ship with capital S, and that the base class is movie clip, which is what I did by choosing movie clip when I created it. So everything is kosher here. So we're good to go. So now let's work on the code. Let me go ahead and press F9 to call, sorry, not F9, F9 here to call the actions window. And let's go ahead and start coding this. So first things first, I want to call the ship from the library. So I'll say variable ship with lowercase s at the beginning of type ship with capital S. Remember, this is the class name, which we shared it with from the library right here. So that is the class that I'm adding to this. And in this case, I only want one ship. So I'll say equals new ship. I only want to add one ship. So that's what I do. I declare new ship. Remember, this capital S matches that, the name of the linkage, and it also matches the class for this, or the data type for the variable that I declared. So I declared a ship. I told the variable, you will be called ship, and you will be of type ship, which is what I just declared you to be here, the class that I declare, and then I'm going to say add one new ship into that variable. Now I need to add it to the stage. So if I go add child ship with lowercase s, because now I'm treating it as the variable, I add it here. And if I run this, the ship will be added on the upper right-hand corner, upper left-hand corner, as I expected. So this is working. Now I need to tell it where to go. Remember, the center point, or the reference point, the registration point for my movie clip is on the top portion of my ship, smack in the middle on the x-axis. So that tells me that if I tell this to be placed, and actually let me do this variable, this properties, assign these properties before I add it to the stage. Let's go ahead and type here ship x equals stage dot stage width divided by 2. That places it right in the middle of the stage. So this is my stage width from here to here. And if I divide it by 2, it places it right in the middle. It makes the x value of my ship appear in the middle of my stage. So if I test this, my ship should appear in the middle of the stage. Now let's take care of the y-axis. For the y-axis, I will use ship.y equals stage.stage height. Okay, and that is the bottom of the stage. So if remember that my ship registration is at the top of the ship. So if I say stage.stage height is going to appear at the bottom underneath the fold. So if I test it now, my ship doesn't show up anywhere because it's down here below the fold. So let me stretch that out a little bit and you'll notice that the ship is there, but it's nowhere in the stage. So I need to subtract the value of the height of the ship from the bottom of the stage, meaning if this was 500, that the position of my ship would be 500 minus whatever the height of that is. And let's say that is 50. So it would be 500 minus 50. That means that y equals 450, which will place it somewhere around here. Since I don't know the numbers, and I don't want to know the numbers, I'm using the actual properties. So stage height minus ship.height should give me the result that I want. It's basically saying whatever this value is minus the height of the ship. And what's the value of the ship? I don't know. Ship height. That's the value of the ship. So let's test this really quick. And there it is. The ship appears at the bottom of the stage, and it is placed exactly where I want it. That's the logic behind placing it and how to place it there. Now, let's add a listener to the ship so that I can move it. Before we do that, I want to create a variable at the very top that I'm going to call variable, let's say, friction. And I'm going to call it fric, or FR for short. Friction. Let's call it friction. Why not? So that we don't tangle ourselves. I'm going to make it a number. And I'm going to give this a value of 10. That is the initial value that I want this friction to have. It's just a variable that I created. I'm going to use that in a formula in just a second, where I can calculate how the friction is going to work. So now let's go ahead and add a listener to this ship that will be checking to see where my mouse is at all times. So ship add event listener, and then that event will be an enter frame event, and it's gonna call a function called move ship. So the function I will declare in just a second. So that ship is now listening for an event listener all the time, and that event is enter frame. Now let's go ahead and at the bottom, let's go ahead and declare the function, and the function will be move ship, and then I'll say open parentheses, and remember that event needs to match the event down here, so this would be event of type event. Okay, so that, remember, this and this one need to match. So if this was a mouse event, this would say event equal of type mouse event. In this case, event is of type event. It's just a simple event. And then I'm going to open up my squiggly brackets and hit return so that I close the brackets at the bottom. And now what is this ship doing? Well, this ship needs to calculate what distance it is from my mouse at all times, and then divide that by the friction variable, and add whatever the result of that value is back onto the position of the ship. So we're moving it on the x-axis. So we're going to say my event target, which is the ship, event target x, that is the x value of my event target. We're going to be doing the operation and adding it back to the x value. That means plus equals. It's an assignment operator. So we're going to say, whatever value comes after that from this equation that we're about to write, add it back onto the x-axis. So what is the equation? Like I said a second ago, we need to calculate what is the distance between my mouse, x, and the actual ship, x, event dot target dot x, and then we take all that, whatever that gives us, and divide it by 10. So, or by inertia, by friction. So friction being the variable that we declared up here. And so now what this is going to do is going to be checking, let's say my mouse is positioned at 100 pixels, and my event target is at 90 pixels. So it'll be 100 minus 90, that would be 10, divided by 10, in this case, by friction equals 10, that's 1. So it'll take 1 and it will add it back to the position of my event target, which is the x value of that ship. So it'll be, it was at 90 a second ago, the result of that equation will give 1, so it will be, the next time around, this will be 91. And then we go into that again. So say mouse x equals 100 minus 91, that's 9, divided by 10 equals 0.9. So it'll add that 0.9 to this value. So it'll say 91.9, and so on. So you'll notice that as it gets closer, that value will be smaller, and that's why it slows down. The further you are, the faster the thing will move, because the difference is more significant. For example, if this was at 300 and this was at 100, then the difference would be, or let's say this was at 500 and this is at 10. So it would be 500 minus 10, 490. 490 divided by 10, that's 49. Add that to that. And so now the next time, instead of being a little move, it's going to be from 10 to 49, that's 59. So that's going to be moving to 59. So it's going to move 59 pixels to the right. So that moves a lot faster the further away that is. The closer it gets, the slower it goes. So if I test this, that should follow my mouse with a lag behind it. The reason why I use the friction variable is because I can, at any time, I can change this. And so, for example, let me do a quick test. So I'm going to say if mouse x is greater than stage width divided by 2. If I have my mouse past the middle point of the stage, then friction, I'm going to make it higher. Friction equals 50. And you'll notice that by doing that, I'm overriding the initial value of this. So when I get past the middle of my stage, my friction will change significantly. Watch. So right now it's all fine and everything is fine. Once I get past it, watch. It's going to be checking to see what the value of that friction is. So let's test this again. It's going to be a lot slower. You see that? So if I make it, let's say, 5 instead of 50, it's going to move a lot faster. Watch. You see that? And that's because I'm changing that value when I get past the middle of the stage. My mouse X is greater than. So I can change that back again by saying else if and adding another condition saying if I'm to the left. And you can change it by changing the conditions such as if a score, if you're keeping a score in a game, for example, or if the user clicks on something, you can check to see what those conditions are, and then you can change those variables on the fly. Let me go ahead and remove that if statement right now because we don't need it. What we need to do is check to see what the position of the mouse is with respect to the ship so that we can make it tilt. So that's what the condition is going to be. We're going to start by saying if my mouse X is greater than the ship, sorry, not ship, the event target, which is the ship, X plus half the width of the ship, which is event dot target dot width divided by 2. So let's organize this. So this right here comes in a parentheses. So it's going to say add the position X plus the half the width of the ship. If my mouse is past that point, so I need to close this parentheses as well, the beginning parentheses. Then open brackets. There you go. Then that means I am past the right side of the mouse. So we're going to say event.target. I keep on calling it, but you can call it ship as well because you're just using one variable in this case, so it will work. Event target go to and stop 2, which is frame 2. Okay? And that's going to make it flip to the right. So if we test that, you see that the ship will automatically tilt to the right, and it'll still tilt it that way because that's the only order we gave it. We told it once I get past, tilt and stay there. We told it to go to and stop. So we need to make it come back. So now we're going to say if it's past the left side, then do something else. We're going to say else if, in open parentheses, mouse X is less than, and that now we're looking for the left side of the ship, which is event dot target dot event dot target. The left side would be X minus half the width, so it would be event target width divided by 2. Okay, so we need to encase that in a parentheses right here. Event dot target dot width divided by 2 minus event dot target X. That's the left side. Or event target X minus, we should move this actually around. Let's get this one. Event target X right here at the beginning of this minus, and let's make sure that I remove this minus from here. So it will say if the event target X, the X position of the ship, minus half its width, that's the left side of the ship. Then open up brackets at the end of that if statement. Remember, we're still stating the else if. And right here, I'm going to say, well, do the same thing. Go to and stop on the second frame, but this time make the scale negative, the value of scale. So it would be event dot, because I wanted to flip on the x-axis, event target dot scale x equals -1. And that means the ship will flip around. Watch. So it is here. When I go to the other side, it will flip to the other side. But if I go to this side, to the right, notice that it doesn't flip back. So that means I need to add that exact same statement to the event target on the previous part of the if statement right here. So after I tell it to go to frame 2, I need to tell it to go to event target x scale +1 when I'm on the right side. So there you go. Now it flips to both sides. But when I'm over the ship, notice that it gets stuck on the frame 2. So that means I need to add another if statement to that if statement. So I'll say else if, which is, these are the only possibilities. Right now, this part of the if statement says if I'm past the right side of the ship. If I'm not past the right side of the ship, then it says if you're past the left side of the ship. If I'm not past the left side, that can only mean one thing. I am over the ship. So I don't really need anything else, any more conditions. You can just simply say else, and then say open bracket, hit return, say event target, go to and stop 1. So we'll borrow this line from here and place it here, and we'll go back to 1. And you can leave the scaling as is if you want to. If you want to keep it the way it is, it's just going to go back to because the ship looks the same on frame 1, whether it's flipped or not. So if now what we're saying again, first part of the if statement from here to here saying, is your mouse past the right side of the ship? And you're going to say, yes, it is. Then go to frame 2 and scale it, positive. Then it's going to say, well, if it's not, is it on the left side of the ship? And you're going to say, yes, it is. Then flip it to the other side and go to frame 2 and stop on the movie. But if it's not, then what else? Well, if you're not past the right or past the left, then that means you're on top of the ship. Therefore, go to frame 1 and stop there. And so now, when I get on top of the ship, I am normal. If I go to the left, it tilts to the left. If I go to the right, it tilts to the right. So as you can see, I am controlling that based on the position of the mouse. Now that you know where the ship is, you can add things based on the position of the ship, or you can add things to follow the ship itself by following the same logic. Basically, what you're doing is controlling the position of objects on the stage by using the concept of inertia, or I'm sorry, not inertia, friction in this case. They also call it inertia, even though it's really not inertia. But it is, because inertia is just, the tendency that something has to continue on what they're doing. So if I'm moving, I continue to move. Friction is what slows you down. So that's why I call it friction. So you have that you have the ability to control the movie clip in that way by adding a series of conditions that need to be met, and by the main line here is how does it follow my mouse? Basically by calculating the position of the mouse versus the position of the object that is following it, subtract that from the position of the mouse, and then divide it by a variable called friction. Now, like I said, friction is a variable so that we can go ahead and change it if we need to by meeting certain conditions. Let's assume this was a game, for example. You want to make the game more difficult. You want to make the ship move slower following the mouse as you progress through the game. So that is a way of challenging your user.